Hello everyone and welcome back. In today's video, we're going to be exploring Chemistry Basics Part 4. Now, what we have learned so far is the structure of an atom. What we know so far is that there's a nucleus and there are electrons revolving around. Now, the nucleus contains protons, which are positively charged, and neutrons, which are not nor negative nor positively charged, so they have no charge. So that's what we know so far about an atom. Now, we are going to look at compounds. What are compounds? Now, when two atoms meet each other and kind of bond to each other, bond meaning if you have this atom and you have this atom, they form a bond in the middle like that. So when they bond with each other, they connect with each other, they found a compound. For example, if I rub this out, this is from the previous video. So for example, if you have oxygen, O2, and hydrogen, and hydrogen, then they bond to each other to form water, because H2, O is how we can write water. H2O is basically water, nothing too fancy in that. So let's see how these atoms bond to each other and actually form these compounds. Okay? To understand that, let's look at another very important thing, which is electron cells. Electron shells. Right? So what are electron cells? If you have this nucleus and if you have these orbitals, these are like the sun and the solar system. They have the sun in the middle and different planets revolving all around it, right? That's the same in an atom, because electrons revolve around the nucleus. So they have orbitals as well. Orbitals meaning little circles in which they can revolve in. You call those shells. Okay? So there is this you can say a name for all the shells. The innermost shell is known as K, then this one is going to be L, this one is going to be M, N, O, P, Q, R, S, T. Now these are all the letters that show us all the shells. So K, L, M, N, O, P, Q, R, S, T. So those are our shells. Now, they have a capacity. The capacity can be written down as 2n to the power of 2. N is the number of shell, meaning if it's K, K is the innermost shell, meaning 1, right? The first shell. So it's going to be 2 times 1 square, which is 1. So 2 times 1 is 2. Meaning how many electrons can K hold? It can hold 2. How many electrons can L hold? 2n square again, which is going to be 2 times the second shell square is going to be 2 times 2 square is 4. 4 times 2 is 8. Alrighty, let's move on to m. How much can m hold? So 2n square again, 2 times 3 square. 3 square is 9, 9 times 2 is 18. So how much can m hold? It can hold 18. Likewise with the fourth shell, which is n. How much can n hold? 2 times 4 square. 4 square is 16. 16 times 2 is 32. Alrighty. So that's our KLMN, which is basically the energy cells, you can say, or the electron shells, or whatever you like, you can call them. Something like that. So let's rub all this mess out and let's talk about another important thing. how do these things bond to each other? Now, there's the aim for each atom. For example, if you even just take hydrogen, this is hydrogen, okay? They have one electron roaming around and they only have one shell. So, the thing is that all atoms want to have full shells or empty shells, okay? What hydrogen wants to do is to either get one more to form a full K shell because K can hold two, so two is gonna be full. Is either get one or just share. Now, for example, if you take helium, helium has two like that, two electrons running around. Now, its aim is that I'm okay. I don't need to bond with other atoms to get more electrons because I'm fine with how many I have. So helium, on the other hand, is non-reactant, meaning it doesn't want to react with other atoms to get more electrons. Okay? So it's all about hydrogen and those atoms like that. Now, we're going to be learning about valency. What is valency? Now, what I told you, this one, how much the hydrogen atom wants to take or give or share, is going to be its valency, meaning the valency of hydrogen is going to be 2. Okay? So, how do these bond? Let's take an example of sodium. Sodium has 2, 8, 1. So, there's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Okay, so it's going to be the 11th element. Now, elements, I haven't told you what an element is. What is an element? Now, all of this that we were talking about, hydrogen, we were talking about helium, the pure type of atom, meaning gold. Gold is an element because that's the purest. You can't break down gold into anything else. You can't break oxygen into anything else. While you can break down water into hydrogen and oxygen, right? So those are elements. Now let's get back to our valence. Now this has 2, 8, 1. So 2 is how much the K shell has. 8 is how much the L shell have. K, L, M. And M shell has 1. Now one thing that so K has a capacity, right, of 2. Now if you don't fill up the whole shell, like the first K shell, meaning if you only have 1 in K shell and if you have 2 in the other one, in L, it won't make sense because K has to fill up before moving on to the other step. So you want full shells before you move on to the other one because the atom can only give away new electrons or get electrons from the outer shell. It can't go from the inner shell, okay? So, we have got 2, 8, 1. Now, what is the valency of this, of sodium? Sodium actually has an aim of giving its one away. Now, let's take take a look at another element, which is going to be chlorine. Let's take chlorine. Chlorine. Now, chlorine has a chemical electron configuration like this. Electron configuration is basically writing how many electrons you have in each. So it has 2, 8, 7. Now, what does chlorine want to do? Chlorine wants to get another 1 electron, so the valency is going to be 1. So it wants to get 1 electron to fill up its cell. And this one wants to give away 1 electron to get an empty shell. So what do? These two atoms come together and give away electrons. So they form a bond. So we have got sodium chloride now. Right? Chloride. We've got sodium chloride, which is basically salt. If you haven't heard sodium chloride before, you're gonna get used to this. Now, another thing that I'm just gonna touch on is the periodic table. The periodic table basically just arranges the elements according to how many electrons they have. So the first element is hydrogen because it only has one electron. But the atomic number normally matters on the amount of protons they have. We're gonna touch on this in the next video, but I'm just giving you a brief introduction. Now, one question might come up to you is that do they always do only the same valence atoms give or share or bond to each other? The answer is no. If you take oxygen, O2, the and hydrogen has one, this has one. So hydrogen needs one, right? And oxygen is there's hydrogen, helium, lithium, beryllium, boron, carbon. So oxygen is the eighth element, meaning there are 8 electrons. So the chemical thing is going to be like 2,6. Now here, hydrogen and oxygen will have to share. How is that gonna work? So here, O2, which is oxygen, and hydrogen are gonna come together, and they're gonna have one electron hanging like that. So now this hydrogen has got 2, this hydrogen has got 2, and this oxygen has got shared electrons from these 2 hydrogen. Together electron make configuration of 2, 8, which is 4 shells or valence shells. So not only same valency can come together, it can be different. Okay, so hope you understood that. Hope you learned something new. And this example that I took was basically what's that? Okay. Hope you understood everything. Hope you learned something new, and I'll see you in the next video. Till then, take care and bye bye.